An implicit function is a function defined by an equation involving the independent and dependent variables without explicitly solving for the dependent variable. For example, the equation of the unit circle x squared plus y squared equal to 1 implicitly defines y as a function of x locally. An implicit function can be plotted. For example, x cubed plus y squared minus 2xy equal to 2 can be plotted. Notice that this piece of the graph is the graph of a function. The remaining piece is also a graph of a function. That is, if we graph an equation by plotting all pairs xy that satisfies the equation, the graph may not be the graph of a function. Here are some examples. However, at any point on the graph, we may be able to find a small piece of a graph that is the graph of a function of one variable or the other. For example, consider the graph of x cubed plus 6xy minus y squared equal to 0. This relation can be solved for y equal to 6x plus minus square root of 36x squared plus 4x cubed, the quantity over 2. Or, after simplification, y equal to 3x plus minus square root of 9x squared plus x cubed. Thus, the graph consists of pieces that can be viewed as graphs of functions of x. At some points, a small piece of the graph can be instead viewed as the graph of x as a function of y. On the other hand, consider the equation y to the fifth minus 5 y cubed plus 4y equal to x. Here, x is explicitly given as a function of y, so the entire graph is the graph of a function of y. Finally, there are situations in which we cannot explicitly solve for either variable. For example, here, the implicit equation is y times quantity y minus 1 to the power 2 times quantity y plus 1 to the power 2 equal to x times quantity x plus 1 times quantity x plus 2 times quantity x minus 1 times quantity x minus 2. Even though we know that a function of x or y exists locally about each point, we cannot explicitly solve for either variable. Implicit curves and ODEs. For example, taking the derivative of x cubed plus 6xy minus y squared equal to 0 gives 3x squared plus 6x plus 6xy prime minus 2y y prime equal to 0, which is a differential equation. We know that the original equation is an implicit solution to this differential equation. You may or may not solve for y prime. Taking a second derivative gives a second order ODE.